today is the last lesson of this 2020 year. The I can statement is going to be, I can tell if two triangles are similar. Okay, I can tell if two triangles are similar. That is what we'll cover today. Okay, so our quiz is going to be on Fridays. So Tuesday, Wednesday, Thursday, we are going to review for our quiz on Friday. So how can I tell if two triangles are similar or not? Here's the way you can try, or here's the way you can tell if two triangles are similar. You can tell if two triangles are similar when two angles in one triangle, two angles in one triangle are congruent to two angles in another triangle. There's a lot of writing here. I apologize in advance. I'll wait for everyone to get caught up before moving on. So when two angles in one triangle are congruent to two angles in another triangle, the third angles are congruent are also congruent. Everyone should be writing this down. And the triangles are similar. Woo, give your hand a little break there. I will give our hands a little break. I'll wait for everyone to be done writing that down. So when two angles in one triangle are congruent to two angles in another triangle, the third angles are also congruent and the triangles are similar. Okay, thumbs up if you are ready to move on. Can I see a thumbs up? Awesome. So here's how you can tell whether two triangles are similar or not. If you have two angles that are equal to each other. So let's take a look at example A. Notice how I have 75, 75. That's one angle, one pair of congruent angles. Notice how I have 50 and 50. Here's the second pair of congruent angles. If you have two angles that are congruent, then your triangles are similar. So similar, explain why, because two congruent angles. That is how you know if two triangles are similar. Well, that seems pretty easy, doesn't it? Well, now let's take a look at example B. Okay, so right off the bat, notice how I have a 63 here and I have a 63 here, but I only have one pair, right? So our initial instinct is to say, no, these two triangles aren't similar, but you can't say no right away. You have to solve for the missing angle first. So let's take a look. Can I solve for x? How can I solve for x? How can I solve for x? Who has an idea? How can I solve for x? Something with 180, yeah. Who else has an idea? How can I solve for x? Something with 180, that's right. But what can I do? What do all three angles of a triangle have to add up to be? They have to add up to be 180. So can't I say x plus 54 plus 63, and that equals 180 just for this triangle? And that way I can solve for the missing angle, right? Does that equation seem familiar to us? Yeah. Right now, let's combine like terms. So I have, whoops, sorry. And then I combine these two like terms here. So I have x plus 117 is equal to 180. I subtract the 117, you subtract the 117, you get x is equal to 63. So instead of x, I could write 63. And now look, do I have two pairs of congruent angles? Yeah, I have 163 and I have two 63s. So that's why you can't just say no. You have to always solve for the missing angle first before you say no. So yes, these are similar. You have two congruent angles. Yeah, so what if it didn't work? What if you didn't get the right one? Well, we'll move on to example 3. Hopefully example 3 will answer your question. So now let's see. Let's solve for the missing angle here. Right now I have one pair, but I need two. So I need one more pair of congruent angles for these to be similar. Let's solve for this one. So I have 90 plus 42 plus x is equal to 180. Right? Does anyone have any questions on where I got that equation from or how I set that up? We're good? Right, I just added 1, 2, and 3 up, and that equals 180. So you have 132, right? If you combine like terms, plus x is equal to 180 minus 132 minus 132, you get x is equal to 48. So this is equal to 48 degrees. So now, do you have two pairs of congruent angles? No, this is 48, this is 42. One of them has to be equal to 38. So if that's the case, are these two triangles similar? Nope. Not similar. Only one pair of congruent angles. Does that make sense with everyone? So you solve for the other value of x. And if both of those values don't equal the other value, then these are not similar triangles. All right. So now why don't you try A, B, and C on your own? Letter C, I will give you a little hint. There are two things. This is going to be two steps. Okay, so I want everyone to write it down for letter C. So take a look, pay attention to letter C real quick. I want you to solve for x first. I know x isn't written there, but I want you to solve for this angle measure first. How? Take a look at my screen. What shape does this create right here? Triangle. So can I solve for the value of x? Yes, right. You can solve, you have this angle measure, whoops. You have this angle, you have this angle, so solve for this angle right there. So that's what you have to do for step number 1. Step number 2, here I'll do this in a different color so it's easier to see. How many degrees does a straight angle have, or a straight line have? How many degrees does a straight line have to add up to? How many degrees does a straight line have to add up to? Does anyone know? A straight line. A straight line has to add up to 180 degrees. Yeah, good. So that means if I were to add this angle right here, and I were to add this angle right here, and I were to add this angle right here, all three would get me 180 degrees. Okay, so use those two steps. So that's what I want you to do here. And I want you to do that part for step 1 right there. And if you do those two steps, you will be able to figure out if these two triangles are similar or not. So I'll zoom back out. Why don't you try A, B, and C on your own? And we'll come back in like 4 minutes. So let's take a look. Right away you notice how, okay, you have one angles that are equal to each other. Now let's figure out if the other angles are equal. It doesn't matter which one you solve for. You could solve for x, you can solve for y. You get the same answer regardless of how you do it. So now let's do x, right? So if I were to solve for x, I have 28 plus 80 plus x is equal to 180. 108 plus x is equal to 180 minus 108 minus 108. You get x is equal to 72. So are these two triangles similar? Yes or no? Nope. Good. Moving on. You have 90 and 90. So that's one angle. And now let's solve for y. Let's see if we get a different answer if we solve for y. So 90 plus 24 plus y is equal to 180. You get 114 plus y is equal to 180 minus 114 minus 114. You get y is equal to 66. So are these two triangles similar? Yes. Yes, question.
I did 90 plus 66, and I got 156 plus x equals 180, subtracted 156, and I got 24. And
Yeah, so you got 24. Did you get the same? Are these two triangles similar still?
yeah, but
Good. Exactly. So I'm glad you brought that up. It doesn't matter which one you solve for. So you could have solved for x first. You could have solved for y first. As long as in the end you get two angles that are equal each other, like as long as that's the end game, then you're okay. Does that help?
yeah, thank you.
Good. I'm glad we brought that up. So I'll put a little check mark here. So for this one, hopefully someone was able to take my hint, solve for x first. 51 plus 90 plus x is equal to 180. So 141 plus x is equal to 180. So minus 141 minus 141, you get x is equal to 39. So how does this help me? Remember, I said for step 2, I want you to make sure, remember, a straight line is equal to 180 degrees, right? So if I were to add this angle plus this angle plus this unknown angle, let's label this as y, that should be 180 degrees, right? So now let's solve. 39 plus 102 plus y is equal to 180. 141 plus y is equal to 180 minus 141 minus 141. You get y is equal to 39. So if that's the case, do I have two angles that are congruent to each other on both triangles? Yeah, you have a 90 and you have a 39, right? So therefore, these two triangles are similar. Does anyone have any questions on example 1 on telling on whether or not two triangles are similar to each other? All right, moving on to the back page. Indirect measurement. Indirect measurement uses similar figures to find a missing measure when it is difficult to find directly. So for example, you plan to cross a river and you want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. Explain why triangle ABC and triangle DEC are similar. So I have triangle ABC, which is a triangle on top, and a triangle DEC, which is a triangle on bottom. Are we all able to see that? Good. So triangle ABC and DEC. Remember, how can I tell if two triangles are similar to each other again? If they what? We just learned on the other side. How can I tell if two triangles are similar to each other? If they use the chat feature to answer that question. How can I tell if two triangles are similar to each other? They have equal measurements, but yeah, two congruent angles. Right away, I notice one angle that are equal each other. Which angle do I notice that are equal each other? In both of these triangles, which angle is equal to each other? There's no number involved. But 90, yeah. Notice I have a right angle. I have a right angle. That's one angle. So now I have to figure out where's the other angle. Do we all remember the term vertical angle? A little bit? Yes, maybe so. So notice right here and right here, these are vertical angles, right? Vertical angles are always going to be congruent, as in they are always going to be equal. How can I tell if two angles are vertical angles? Well, remember, if my lines make an X, notice how my lines make an X, then the angles on the other side of my X's are always going to be congruent. So in this case, I have, yes, these are similar. Why? Because you have two angles congruent. Where are they? There, you have the right angle and you have the vertical angle. Okay. So now what is the distance X across the river? So this is where you make a proportion. So proportions are from pre-algebra chapter 5, if you want to remember that too. So proportions, excuse me. So in this problem, it's going to be, you're going to have two fractions that are going to be equal to each other. So now let's start with this 40. This 40 on the other triangle, what does a 40 correspond to? What number does 40 correspond to on the other, when I want to compare it to the other triangle? 50. So 40 over 50 is equal to, all right, now let's put X equals X over what number does X correspond to? 60. Good. Do we all see how we set up that proportion or this equation? Do we all see it? Right. So 40 over 50 is equal to X over 60. And then now let's solve for X. Let's simplify. These zeros cancel out. 4 over 5 is equal to X over 60. Oh, and there's 3 different ways you can solve this. I'll do all 3 real quick. So take a look. I would say the first way is the easiest way, but let's see if you were able to notice this as well. How do I go from 5 to 60? How do I multiply by 12? So if I multiply by 12 on the bottom, what do you think I would do on the top? The same thing, multiply by 12. So 4 times 12 is 48. So X is equal to 48. Do we all remember that from last year? Yeah, good. All right, next method. This is called cross multiplication. Do we all remember this? Or we make that double butterfly kind of thing, right? So you have 4 times 60 is equal to 5 times X. So that's 240 is equal to 5X. Divide by 5, divide by 5, and still you get X is equal to 48. So no matter which method you choose, you get the same answer regardless. All right, last example, 4 over 5 is equal to X over 60. Well, what operation is going on between my X and 60? What operation is going on? If it's a fraction, that means it must be what? Fraction means what operation? Yeah, so fraction means division. So I want X alone, so I could do the inverse, right? Instead of X divided by 60, can't I do X times 60 to get rid of these? You multiply by 60, so you have 60 over 1 times 4 over 5. Cross simplify a little bit here, and you get 12 times 48. 4 over 12 times 4, which is 48, over 1 times 1, which is 1, so you get 48. So no matter which method you choose, you get the same answer regardless. Awesome. All right, last example that I want you to do, an example to assume that the distance between vertex A and vertex B is 55. So instead of having this as 60, you want it to be 55. What would be the new distance across the river? So let's do this one together. So what's the proportion that I would set up? Instead of 60, it's 55. What would be the new proportion that it would be? What's the new proportion that I would write to solve for X? What is the new proportion that I could set up and solve for X? Yeah, I could write 40 over 50 is equal to X over 55. Let's simplify this a little bit. So 4 over 5 is equal to X over 55. How do I go from 5 to 55? Yeah, you multiply by 11. Multiply by 11. So you get 4 times 11 is equal to x. So you get x is equal to 44 feet. Does anyone have any questions on this? Okay, awesome.